just all off the rails. And I think that coupled with officers pulling back, not wanting to be on the roads and focusing on other things, kind of just became this negative feedback loop. We had a goal of in 2020, like right before the pandemic, like let's try to get to 225 by 2025. Has a nice ring to it, right? Not to say it's impossible to get there, but it's looking hard. We're going to get there. But you know, wouldn't it be great if no more than 225 people died in 2025 in Minnesota from traffic-related fatalities? But you know, we need a new approach, right? Things aren't working. So, you know, we must do things differently. One thing that we did was we looked at this thing called TZD 2.0. We've had TZD in place for about 20 years now. Let's take a look at it. Let's refocus it. What are we doing wrong? What's working well? What can we do next? And really kind of the two things that came out of this study, or this kind of this cultural study we looked at, was this idea of the safe system approach. How can we implement this across the state? And then this idea of traffic safety culture. And we have a researcher out of the University of Montana who's really big in this traffic safety culture thing, and it is fascinating. How do you change a culture, and how do you change a culture for the good? And it's remarkably complex. How do you change a culture? Changing a culture takes 20, 30, 40, 50 years sometimes. And you know, the example I'll give is, think about smoking. Back in the 60s, it wasn't a really big deal for people to smoke at their desks and smoke in the elevator and smoke in their cars, and you know, smoke pretty much everywhere. You know, if this meeting was in the 60s, there would probably be a haze on the top of this room, right? Because we'd all be busy smoking, right? You don't have that anymore. That isn't acceptable. And really that took a lifetime. I mean, that's something that probably within even our own lifetimes, I won't say my age, but you know, it's something that when I was a kid that may have been more acceptable. Now that's unacceptable. But it took a generation, it took a long time for that culture to shift. And that's the same thing we have to think about on road safety. Is this isn't going to change tomorrow. This isn't going to change next week. This is something we have to start thinking about, you know, for our children and our children's children. So first one here I'm going to show is a little video. This is from Australia. The Australians are really big on this safe system approach. And I'll share another video too, but I'll say this one's pretty mild. The Aussies are like brutal when it comes to videos. Hopefully, can you guys hear that?
The safe system is all about changing the way we view the problem and the way we respond. And a lot of the jargon is around a paradigm shift or a transformation.
That's also familiar.
Fundamentally, we're moving from a historical base where we thought we could make the driver and the road user perfect. I'm an ex-teacher. I came into road safety a long time ago. My background sort of told me we could educate our way out of this. While education remains really important, we can't educate our way out of this. And the reason we can't do that is because people make mistakes. They always will make mistakes. We think that we can make humans perfect. In 55 or 60 years of their driving careers or road using careers, we're barking up the wrong tree. So the safe system basically takes that as one of its first principles. Firstly, acknowledge that people make mistakes. Secondly, it says we brake, and we brake at relatively low speeds. So a car hitting a pedestrian at 30 kilometres an hour, there's a 90% chance that pedestrian won't be killed or seriously injured. If they're struck at 50, there's an 80% chance they will be killed or seriously injured. So in a short space of kilometres an hour, those impacts make a big difference. So we can manage the energy in the system and move our focus from the problem of trying to stop crashes to trying to stop the consequences. So if and when I crash, can we prevent the consequences from being severe? The other fundamental basis of it is, so it's all about, can we prevent those crashes, but can we also manage the consequences? And the other key thing is there's a shared responsibility, and we need to move all parts of the system. So if there are levers that we can pull, we need to educate, we need to enforce, but we need to re-engineer the environment. And that's both the speeds at which we travel and the interaction with the environment we're in, with the combined with the safety of the vehicle. So it's a fundamental shift from thinking we can educate our way out and make people perfect to a system approach where actually we know that you're going to make a mistake. So when you do make a mistake, can we manage the environment so the consequences aren't serious or fatal?
All right. So that's one of the that's the Aussies there. That's what I'm talking about it. But really, it comes down to these two fundamental principles, as you said. Really, this idea is we need to accommodate human mistakes. We're going to make people perfect. We know people screw up. They screw up constantly, and we just have to accept that. And we have to know that, and we have to build that into our designs. But then the next part is really how can we keep those impacts on the human body manageable? intolerable so that people can survive these crashes. Nobody should have to die in a roadway collision. This is a good saying, but a system that is safe only if people don't make mistakes is not a system made for humans. It's just reality. If you've ever worked in a factory or you know, as a cook or any kind of, you know, if somebody kept getting hurt on the same piece of machinery over and over again, would your boss just say, or would you say if you were the boss, like, yeah, people are dumb, they're going to keep screwing up and I'm not going to do anything about it? Or do we look at it and say, why do people keep screwing up and what can we do to prevent them from doing it again? That's the whole idea of the system. Is the system should be accommodating to that. We should figure out why do people screw up and how can we do what can we do to prevent that in the future? So this has been pretty successful. Sweden was one of the first ones to do this. Netherlands, Australia, New Zealand all kind of implemented similar approaches, all have different names, but really they've all kind of seen this 50 to 60 to 70% reduction in fatal fatalities in the 20-year span that they've had these in place. So they have been very successful in these. US, we have a lot of similar programs or similar names. You probably heard, you know, Minnesota here, we have Towards Zero Death. Other states have the Road to Zero. There's the Vision Zero Network. There's the Towards Zero Death National Strategy. So we kind of have similar things of a similar flavor across the country that have been used and kind of have the same approaches. But hopefully with the safe system approach is this idea of this whole kind of comprehensive approach that we can all communicate and speak the same language. So this is what we call the wheel. This is kind of what the safe system approach is in the center here. This is called the principles, or I'm sorry, this is the elements. The elements are what we're going to use to get to the principles, and the principles are the ones on the outside here. We'll go through each of those and what do they mean. So like I said, these are the principles. These are the 6 safe system principles. You can see them around the outside here. And then here's the elements, like I said. But here are the principles. Really, the idea is 0 deaths is our goal. Death and serious injuries is unacceptable. We do not want to allow these on our system. There's no reason they need to happen. Next one, as I said, humans make mistakes. We have to acknowledge humans make mistakes. Humans are vulnerable. As the road commissioner said there, we brake at a low speed. Our bodies were designed that if maybe we fell off a cliff, we'd be okay. We don't really live in the world anymore where we have to deal with cliffs very often, but we do have to deal with high-speed vehicles. But we brake, and we brake very easily. The next one is responsibility is shared. No one person in this room, no one agency, no one state probably by itself is going to be able to conquer this all by themselves. We all need to work together, and we all need to acknowledge that we need to work together. The next one is safety is proactive. We cannot sit and wait for something bad to happen before we do something. We have to know what the typical, you know, why do these things typically happen? What's the root cause of all these things? And then be proactive. How can we mitigate that risk before it becomes a problem? And then as I was telling Casey this morning, I said, redundancy is crucial. I brought my laptop. She brought her laptop. I brought a USB drive. We sent it to ourselves in an email. Redundancy. And redundancy is crucial because we need all these things to work together because each of these parts are going to break and they're all going to break on their own at some point. But we need that next layer there, that redundancy to make sure that it doesn't become a fatal crash. So as I said, death and injuries are unacceptable. People make mistakes. How many people have been in this situation, either as the driver or as the pedestrian, right? We all make mistakes. We all think we're faster than we are. We all think we have better perception than we are. We think we have faster reaction times than what we do. We all make mistakes. And it's not a matter if we make mistakes. It's a matter of when is it going to happen and what are going to be the consequences of those mistakes. Humans are vulnerable. Managing kinetic energy in the system is very important. It doesn't take much more energy to go from a serious injury crash or even an injury crash to a fatality. So if we can manage the energy in the system, that kinetic energy, it can make a huge difference on the users of that system. Responsibility is shared. And the first one I point out here is system managers. I work at MnDOT, I'm a system manager. We work, we plan, we design, we build, we operate, and we have a lot of maintenance workers out there maintaining the system, but really as system managers, as I said before, we know people make mistakes and we know humans are vulnerable. So as a system manager, as a system designer, what can we do to minimize the risks knowing those things? Safety is proactive. I don't think anybody's too surprised by that statement, right? The goal really with this is identify risks, not just crashes, identify risks. And then how can we mitigate those risks? And it's not just how do we do it at one intersection, not how do we do it at 1 mile of roadway. How do we, as MnDOT, how do we do it for 12,000 miles of roadway, 20,000 intersections, 750 interchanges? How do we do that? How do we identify risks and how do we mitigate those risks? And then on top of that, how do we help our county partners and our city partners? Our cities have 30, our counties have 30,000 miles of roadway, 40,000 miles of roadway. I don't know how many thousands of intersections, it's a lot. But they have even more of the system. So how do we help them identify risks and how do we help them mitigate those risks? Redundancy is crucial. I'll say it again. Redundancy is crucial. Should I say it again? So really, this idea is with redundancy being crucial is that, as I said, no one part of the system is going to be perfect. It's going to have holes in it. It's going to have its flaws. So how can we make it so that we can make sure that we have safe road users, safe vehicles, safe speeds, safe roads, and then when all those things fail, if all those things fail, consequentially, what's that post-crash care look like? How do we make sure that those who we failed as a system, how can we make sure they get the best treatment possible so that they don't have to die from those injuries? Talked about those. These are what we call the elements. So before I talk about principles, these are elements. Anybody ever seen this before? The Swiss cheese model? It's pretty big in public health. Actually, it is for public health, I should say. So really, the idea is that, as I said, no one layer is perfect, but if we have enough layers and the holes are small enough, one of those layers is going to break the chain of reactions to get there. So, let's use the example of a drunk driver on the road, right? Is he a safe road user? Not really, right? He's driving an old pickup truck, doesn't have seat belts in it, has the old bench seat in it. Not really a safe vehicle, right? He's going 75 down a 2-lane rural road. Not really being a safe, he's not really traveling at a safe speed anymore. He goes off the road. We've done no maintenance out there. We haven't fixed this road in 50 years. There's trees all over the place. He hits a tree, flies through the windshield because he's not wearing a seatbelt. And since he's out in the middle of nowhere, he lays in the ditch for 3 hours before somebody finally comes along. He's dead, right? That's a death notification. Ask any state trooper about the worst part of their job. They're all going to tell you one thing: death notifications. They all remember every single one they've done. They all tell you it's the worst part of their job. They hate it. They understand it's important, they'll do it, but absolutely hate it. Having to tell a family member they're not coming, having to tell a family member that their other family member is not coming home. So what does this look like in the safe system approach? Right? We got our drunk driver. We know people drive drunk, right? Safe vehicles. We know we can't reach every vehicle. We know that old Chevy is out there with no seatbelt. We know this guy's going to drive 70, right? It's going to happen sooner or later. But what can we as engineers do to make a difference? We clear that road. We clear the clear zone. We get rid of those trees. He goes off the road. He gets stuck in the mud. Officer drives by. Notice he's drunk. The guy goes to the drunk tank, right? He's got consequences. He made mistakes. He's going to be paying, probably going to be paying a lot, but he's not dead, right? Officer doesn't have to go to the family anymore. You just made the difference. We just broke the chain. The Swiss cheese layer worked. So that is the safe system approach. That's what I wanted you to think about, is that no one of these systems is going to be perfect. No one of these layers is going to be perfect. But if we can do just one thing in that chain, it becomes a drunk tank and a DWI ticket rather than a fatality and a funeral. I've joked, if I was the drunk and my wife got that phone call, it would probably be a murder, probably be a homicide, but it wouldn't be a crash fatality. So, I guess it's all perspective. So safe road users. This is all part of it too. We can design a lot of good things, but I need people to play their part. I need everybody to do their best. When we walk safe, bike safe, I need people to drive responsibly. Transit to be effective and to be, I'll say, redundant. It needs to be reliable. And then others, how do we accommodate all these people in a roadway that's a very complex environment, especially in the urban areas, but we need our road users to play a part as well. Safe road users, this gets back to all of us on our individual choices. Shouldn't be distracted or impaired when driving. Follow the rules. I always tell people, like, if everybody followed the rules and like actually, did what they're supposed to do when they're driving and walking, like, I wouldn't have my job right now. Which would be fine, which would be great. If I didn't have to do the job I did, that'd be great. I'd go do other things. But and then the big thing too is acting through the limits of the roadway design. We can design roads really well. We do a pretty good job. But somebody driving 70 on a road that's designed for 40, it's not going to work out real well. So we all need to act within the limits of the roadway design as well. So just in relation to other EVs, once again, we know people make mistakes and poor choices. It's not wearing your seatbelt, that's speeding, impaired driving. That's becoming, it's always been a big deal with alcohol. It's becoming a bigger deal now with drowsiness, just it seems like people are more overwhelmed than ever before. Legal drugs is, you know, we always talk about illegal drugs. That's a big thing, you know, especially marijuana is becoming a bigger deal, but legal drugs is another one. People don't think about how their drugs are going to impair them or impact them while they're driving. And then kind of the other one too is combined drugs. You know, you may take two things that are normally, you know, perfectly legal and fine to take on their own, but when you combine them, they can have that ill-gotten effect. Distracted driving. We look in the crash data, we try to figure out how big of a problem this is, and all we can say is it's probably underreported and understated. But you know, education and enforcement can influence these behaviors. Having those officers out on the roadway can have a big impact. I'm sure some of you probably heard the halo effect before though too. People behave really well around police officers. They'll drive the speed limit, they'll pay attention, they'll put down their phone. Officer leaves to go somewhere else and people are right back to what they're doing. So enforcement's extremely important, but its impact is pretty limited. So, and then traffic safety culture. How can we, as I said before, how can we change a society? How can we change a culture to understand how important all this stuff is? Vehicle safety, you know, active safety, you know, right now a lot of the vehicles are coming out with some of those lane departures things where you're driving along the road and it tells you to stay in. Autonomous braking, how many people have gotten to use their autonomous brakes on their vehicle? No one. Driving too fast, not paying attention until your car slows down because the guy in front of you suddenly decided to slow down. Yeah, they're great. Don't become reliant on them though. And then, you know, kind of the protective systems, these passive systems, and the auto manufacturers have stepped up for decades with this stuff. But, you know, right now seatbelts are mandatory. At one point, seatbelts were mandatory. Airbags, you know, every new car now has a pretty good airbag system within it. And then these crash and burning vehicle crumple zones and steel bars and structural reinforcing and that glass that doesn't like break into those really sharp shards like it used to. So all these passive safety things have certainly contributed a lot too, where people don't have to get impaled on the steering wheel anymore. Vehicles have come a long way. Oh, yeah, go ahead. I don't have any directly here, but it's been pretty big. I think before the seatbelt law went into effect, we were at 60-something% for compliance, people wearing their seatbelts. I shouldn't call it compliance. People were wearing their seatbelts about 60% of the time. Since that legislation has passed and since it's been out there now for a number of years, I think our last seatbelt survey, we're at 93% of people are wearing their seatbelts while they're driving, which is huge. And it's even got to the point now where we're to this point now where more people will die in traffic fatalities wearing their seatbelts than not wearing their seatbelts. Now that, you know, it's about 50-50 now, but that 7% who's not wearing their seatbelts are making up 50% of fatalities. So once again, if everybody wore their seatbelt every single trip, we'd probably save 100 lives a year. Once again, why, you know, I find it weird that that's a controversial thing is wearing your seatbelt. It's so easy, it's so simple, and it makes such a huge difference every time. Other road system users, you know, right now we're trying to see bike and vehicle detection systems within cars that can identify those things. But what's becoming kind of a counter problem is vehicle size and design. Vehicles are becoming bigger, they're becoming more powerful. If you see some of those new trucks out there, I mean, they've got that grill in front of them that's like this. If you're a pedestrian getting hit by that truck going 40 miles an hour even, that can be pretty lethal. So the vehicles are getting bigger, they're becoming more powerful. And that's kind of one of the thoughts behind why those pedestrian fatalities are rising, is just the vehicles have become so much bigger and so much more powerful. But you know, there's kind of always the hope of the new technology of things like connected autonomous vehicles will come and save us. Everyone says it's coming tomorrow. I've been hearing that now for 12 years, 13 years. I'm sure people have been heard it even longer that connected autonomous vehicles are going to save us. I'm not seeing it. So we got to do other things. Create and implement the technology, use education enforcement to make sure the vehicle is roadworthy. Car seats are properly installed. How many people have little kids? Did you put your car in, or did you put your car seat in right? Do you know if you put your car seat in right? Are you sure you put your car seat in right? Yeah, fire departments are great for this. Go bring your car to a fire department, have them check your car seat. It's remarkably important. If that car seat can move at all, as I found out, you did it wrong. If it can move even just a little bit, you did it wrong. Go and have them help you. Really lock that sucker down. I don't know how many crash reports I've seen over the years where everybody in the car died except for the infant who was strapped into the car seat, because that's probably the safest seat in the car now, especially when it's installed properly. Oh, speed. How many people drove here today? All right, who went over 50 miles per hour when they're driving today? 60, 70, I'm gonna put my hand out, I think over 70 days. We had one high flight, that's fine. I'm sure it's probably out on I-94 where it was 70 miles an hour, right? Yeah, exactly. So, speed is at the heart of a forgiving transportation system. As this says, transcends all aspects of safety. Without speed, there can be no movement, but with speed comes kinetic energy, and with kinetic energy and human error, comes crashes, injuries, yeah. And that's from the OECD, which is the Organization for Economic Development. Once again, you get back to the Swiss cheese, we can manage that speed, it can make a big difference. And just, so what does this look like in the real world? I probably kind of gave this one away already, but this is an example. This is things that we see as crash reports when they come in. Driver was going down the road, lost control of their vehicle, fell asleep, wasn't paying attention, whatever it was, goes off the road. It's a 15-inch tree, dead center. Guy flies through the windshield, car rolls, sometimes rolls on top of them. It's horrible. It's not they just die. They're murdered. They die violently. What can we do? I kind of gave you the answer, but what can we do in this situation? What good have we done? Take that tree out, right? Right? I like trees. I love trees, but trees belong in the right place at the right time. On the roadway where someone's driving 60 miles an hour might not be the best place to have a tree. So yeah, we removed the tree here. This guy goes a little bit further, probably still gets banged up. Probably still, has to call the wife and the tow company to get the truck out of the ditch, but he's alive. This one here, this is the one that we saw. This is right out of crash report. Guy driving down the road, going probably about 70, truck pulls out, make a left turn. Truck decides that he needs to wait for another oncoming car. His ass is hanging out in the lanes. Car comes by, clips it at 70 miles an hour. Guy died instantly. What can we do in this situation? Any ideas? RCI. We call them J-turns now. J-turn, yeah. We don't allow this guy to make this move, right? Why are we letting this guy make this maneuver? He's pulling out right in front of traffic. Let's just not let him do that. There's just some other things we could do too, but this is kind of the question we always have to ask ourselves now. Or the way that we need to look at this from the safe system approach is, instead of asking who or what caused the crash, instead of saying, well, that guy was drunk, that gal was distracted, it was icy out, there's all these things that we say. Instead of asking who or what caused the crash, we should instead be asking, how did the road system as a whole allow this death or serious injury to occur? What do we do? What was the system failure? A crash needs to be considered as a system failure. They got through all those holes, right? They got through all those layers of cheese. It's not just a user error, it's a road user system failure is what it really is. And that's what we need to look at it as. So here, we kind of talked about that truck pulling out, here's what they did down in Heron Lake, which is on Highway 60. They built the J-turn. They don't allow people to pull out anymore. You can't cross this intersection anymore. Used to be, you could just cross right across here. Can't do that anymore. You gotta go right, go down a little bit to a U-turn, hit the U-turn and come back. Remarkably effective. We found that we've reduced fatal and serious injury crashes by 70% by using this design. Remove that. You got to go down and make this U-turn now. We're doing this in Highway 212 here. They're expanding 212, hopefully. I think I've been saying hopefully now for like a decade, but I think we're getting closer. But really, the mayor of Cologne, which is on 212 here, said, we will not allow this road to be expanded without the use of J-turns. We are not going to let anybody just cross the highway anymore. It's too dangerous. Do you want to cross 212 now? You come up, you make a right, and you come down and you make that U-turn. That was kind of just like a condition of the project. We're not even going to allow people to make that crossing maneuver anymore. Crash avoidance technologies. I think my slide gets mixed up here a little bit, but that's okay. This is more stuff in the vehicles. Here's the Australian PSA.
What you're about to see will change your mind about speed. Two identical cars, one travelling at 60, the other at 65. A sudden change on the road ahead. Both drivers first react, and then a moment later, they brake. And things start to get interesting. Down here, the difference is extraordinary. In the last 5 meters of braking, you wipe off half your speed. So this car is still doing 32 Ks when it is. This one also hits going up you 5 Ks. So no matter how good a driver you are, 5 Ks difference up there makes 27 Ks difference down here.
So that's a good example of what the Australians do, and kind of talks about speed a little bit, but I mean, I'll say this, if you ever watch the Australians' other PSAs, they are brutal. They do not hide anything. You probably won't ever want to drive like over 20 miles per hour again, after some of their PSAs, because they don't hide anything. You know, Ian, the roadway guy, talked about this earlier, you know, just that difference of speed can make, especially in urban environments with pedestrians. You know, once again, speed overall. And depending what you're hitting and what's going on, you know, that percentage of a fatality just goes up as that speed goes up. So how can we manage that speed within the system? You know, here's a good example of this. This was an intersection. This is off I-35 and Cloquet there. I think this had a fatality and serious injury in a pretty short order. Really, the big issue was people are coming off 35 to go on Highway 33, and they come up over this ramp and they're probably clipping along 55, 60, 70 miles an hour, depending on the day. And really, this was kind of a blinded intersection. People are having a hard time making that turn. So I mean, what they did was they built a roundabout there. And what that really does, what that allows, and we get comments on this, people like are mad. They're like, well, you come over this hill now, you got to slow down and you got to go through this weird little shimmy. And then and we say, we designed it that way. That's what we wanted. This whole idea of this shimmy before the roundabout, this drastic right to the left and left to the right, we do that intentionally. It puts this pit in your stomach. Something feels wrong. So what do you do when things feel wrong and you're driving? You slow down. And that's what we do intentionally. So as you come up and you slow down, we just manage all that kinetic energy. People coming south on 33-2, they'd be clipped along pretty good. Same thing. They get that pit in their stomach. They feel like something's wrong. The energy isn't feeling right in the car. They slow down. They react. They go through that roundabout at 15, 20 miles an hour instead of 65 or 70. Now we've just managed that system, that energy in the system. This is 316 in Hastings. This is kind of a similar project. We were originally, this started out just as a mill and overlay project, and the residents, people who lived along here said, no. You are not going to allow people to drive 60 miles per hour through our neighborhoods anymore. You guys got to do something to slow them down. So what MnDOT did was it came back with this divided 2-lane concept with many roundabouts at a number of the intersections. And with that, we were able to, for the most part, drop a lot of the speeds up there, and manage that system energy again. And this is an area with a lot of pedestrians and a lot of people walking along the roadways. And you know, we've done a lot of critiques on this one. We've learned some things, but overall, pretty good project. West Superior Street in Duluth. This again, kind of this idea of this shimmy, this chicane, that as you approach an intersection or as you approach this pedestrian crossing, people slow down. They want to slow down because everything's telling them to. Allows for a safer pedestrian crossing. Oh, let's see. Skip that one. Yeah, so you know, this whole idea of safe roads is really this idea. You know, number one, we do want to prevent crashes, but we kind of have to accept that crashes are probably always going to happen. So no matter what we do, people are going to crash. But really, the big goal then is let's keep those impacts on the human body at tolerable level. So let's make sure that everybody can survive those crashes. And you know, we do that by a couple different ways. We separate users in space. You know, we give people their own space to walk. We give bicyclists their own space to bike. We separate users in time, you know, such as a traffic signal, we let pedestrians walk across that. Same thing with drivers going across that signal. We use that time differential to make sure people can cross safely. And then this idea of kind of increasing attentiveness and awareness. Like we've kind of learned to come to accept too that with drivers, you get a pretty narrow window of their attention spans. I have to concede, I'm not going to get your attention all the time. Not going to happen. But if I do need your attention, I need your attention. I want it now. This thing's flashing, this RFB flashing as pedestrians crossing. I need your attention now. Go do whatever you need to do before 50 miles you were driving before this. You weren't paying attention. I get it, but pay attention now. I want you to pay attention right now. This is the time I need you to pay attention. So that goal of just getting that attention and acknowledging that we're not going to get your attention all the time. We hope, I wish everybody paid attention all the time, but it's not going to happen. People make mistakes, right? Managing speed's hard. I wish I had more tools in my toolbox for managing speed, but you know, we do our best. But then this next part too is this idea of manipulating mass. And that's the whole idea with a roundabout, a J-turn and interchange, is this idea that when two people hit at a right angle, that's kind of, that's about transferring as much energy into a human body as you can get. But really with the idea of a roundabout, a J-turn, is that we shift that mass. As you enter that roundabout, as you make that U-turn and a J-turn, we've manipulated the mass of that vehicle. We've put that mass somewhere else where it's not going to go directly into the human body. It's going to go somewhere else. And that's what we want to do. So we manipulate the mass, we manipulate that speed. Just like here, yep. Manipulating the crash angles. Someone gets into a crash here, it's going to be that side swipe crash, right? It's not going to be a head-on T-bone type crash that can be so deadly. And the other thing about safe systems is, remember, this is not just a design thing, but really we need to figure out how to design our road safer. How can we construct our road safer? Big thing, maintenance. Maintenance is always kind of the forgotten child. We build a lot of things, we design a lot of things get constructed, and then we hand the bag over to maintenance and we say, you guys have fun taking care of it, see you later. But maintenance is crucial. Keep them in the conversation and make sure they can maintain something, because if we can't maintain it, we probably shouldn't be owning it or building it, and then ultimately operating that as well. Here's a good example of another project for safe roads. This was Glenwood. Everybody in Glenwood was really surprised, or I'll say people were surprised when people in Glenwood said, everyone drives really fast through our city. Everyone's going 70. Look at that picture. Anybody have any idea why somebody would drive 70 through Glenwood? Is there anything telling you to slow down in Glenwood? No, it's a racetrack. We built an airstrip through Glenwood. And, everybody was surprised that people are going 70, even though we had that little white sign that says 30 on it. Like, nobody paid attention to that. Like, I wonder why. But so when they came back to redo the project, and this is what can be really hard to convey with the public, is this kind of fix where we go back and we can narrow up the road and we can make it feel like an actual city street that you should drive at 30. These projects come along once in a lifetime. When we come out there to do a road like this, a project like this, we're not coming back for 50 years. The way the department's budget is right now, the way our resources are, this is a once in a lifetime project. So, we try to tell communities, and, if you're ever in this situation too, do you want this for the next 50 years or do you want this for the next 50 years? Because ultimately, once it's built, we ain't coming back. So how can we build a safer road? And ultimately, it's going to have to be out there for a really long time. Talked about that. Same thing here. I always think, where did you drive the slowest today, for those of you who drove? Like coming onto campus today, right? Like, did anybody go over like 15 driving on campus today? Because especially when the students are walking around, right? Like, you're just like, man, don't want to hit anybody. So yeah, this idea when people are about, we've got these, all these design elements to slow you down. It can be really effective, but once again, we only get your attention span for a limited amount of time, 5 minutes. All right. So other things, road, rumble strips, cable median barrier, all these other things that we do. Here's another example. I'll hurry up here. I'll see what else we got. Have any other points? Oh, then this post-vital care. So, you get into a crash, let's make sure first responders can get there fast. We get you to the appropriate medical care. It used to be, let's just get you to the closest hospital as fast as we can. The mentality on that has switched. It's now, let's get you to the right facility as quickly as we can. Crash investigations, we have troopers who do that. Traffic incident management. So if a crash does happen, let's make sure we don't cause a second crash. And then ultimately justice for those who are injured in that crash, justice for those who violated, whatever. And then, so statewide trauma system, I'll just talk about this briefly. This was the idea that if you're in a crash, let's get you to the right trauma center as quickly as possible. Statewide, I think something like 97% of the population lives within an hour of a level 1 trauma center, whether that's by helicopter or by ambulance. And this has made a huge difference. The level of care you get and the quality of care you get within that first hour of the crash is absolutely vital. That will determine likely the rest of your life, if it is that much longer, depending on how severe those systems are. This was established in 2005. This doesn't just pertain to car crashes. This is probably any kind of trauma that somebody can get, whether that's on the job, at home, or in a car crash. Let's get you to the right place as quickly as we can. This is something that they've started doing too, is this idea that when a crash is called in and it sounds like there's any kind of injury severity, they call on the helicopter, especially in rural parts of Minnesota. They get that helicopter there as fast as they can. It's called auto launch. The helicopter just goes. And then if they don't need it, they can call it off. It's easier to call it off than have to bring it in. So reduces the hospital time. This is something that North Memorial has started. Statewide, they pretty much have all the state covered, but makes a huge difference. So those 4 E's, the Swiss layer approach. So this is really this is what we want to think about going forward, is that traditional approach was prevent crashes, improve human behavior, like just be better drivers, people. Come on, work with me. Control speeding, speeding as an afterthought of behavior. Individuals are responsible. Like if you're in a crash, this is all your fault. This is your problem. And then, let's react to crash history. Let's look at the crash history, and wherever we see the most black dots, that's where we'll go. But now the safe system approach is switched. Jolie, let's focus on those death and serious injuries. Let's design for human mistakes and limitations. So reduce that system kinetic energy. We all have some responsibility in this, and then let's proactively identify and mitigate risks instead of waiting for them to happen. Yeah, so once again, we all have a role to play. We have a shared responsibility. Anybody have any questions? Do we have time for questions, or we gotta go? Sorry if I went long. Anything online? Yeah, go ahead. Oh, go ahead.
Do you know, are crashes more often, are fatal crashes more often happening on like the high speed big roads or local roads?
Yes. No, they occur on both. It's actually pretty split. We see a good split between, it's about 50-50 between urban and rural now. And then it's kind of about 2/3 of our fatal and serious injury crashes actually happen outside of the metropolitan district. So there's a bunch of different ways you can split it. It's not all one or the other. It's usually pretty evenly divided across the state and context zones. So yeah. And pedestrians in Minnesota are typically 50 to 60 fatalities per year out of our typical 400. So typically that 10 to 15% range. So in the back there.
What did you study?
What's that?
What did you study?
What did I study? I did civil engineering. Yeah. John.
Motorcycles.
Motorcycles. What about them?
Well, they have completely different speed threshold
Yep.
for injury. We're designing only for vehicles, for cars. So putting it 30 miles an hour is
Yeah.
fine, but hitting somebody at 30 miles an hour with a motorcycle, it's a completely different story.
Yeah. Motorcyclists are probably one of the hardest parts of the system. You've got both the speed and the vulnerability all rolled into one, right? I'll say, driving your motorcycle at 70 miles an hour, going off the road and hitting anything isn't going to be a real fun day, right? And this year motorcyclists are up. I think we're higher this year for motorcyclists already mid-October than we were all of 2021. And 2021 was a bad year. So,
Why don't we have a helmet law?
great question. If you have the answer, let me know. It was repealed back in 1978 and there's no political muster to bring it back. So, motorcycle, it almost make a huge difference. Go ahead, Danny.
Yeah.
Oh, do I have my reason to pass?
What impact do you think the way the state's transportation system and responsibilities of how they're organized has on crash rates? I mean, Minnesota's pretty much a top-down state. As a traffic signal guy, I've worked in a number of states, and like the state of Iowa, only runs about 15 signals. Everything else is left up to the cities, and so sometimes the mayor appears to be doing the timing at the signals. Tennessee operates none. There are no signals operated by the state of Tennessee. It's all to local levels. So, yeah, a lot of stuff Minnesota's doing is pretty good compared to some of the other states.
Yeah.
I mean, I'm trying to put a plug in, I guess, but I think that's a question, and maybe I'm using a good example, but maybe there's some bad examples out there still within the state of Minnesota about how responsibilities are shifted down. Wisconsin, the counties do the highway maintenance.
Yeah.
I've been driving on 94 and in a snowstorm and the road's nice, and all of a sudden you come to the county line and the plows haven't been there in that county.
Yeah.
All right, I just want to thank ITSO for allowing us to come here, and our meeting sponsor, Bolton and Mink. Thank you